Sir, visible, sir.
Yeah. So in the last class, we studied Gilbert cell. So what is the advantage of Gilbert cell? Actually, to accommodate the two advantages. One is the what? Small signal gain of the circuit is function of the tail current, and one more is the differential pair. Okay. So the tail current is depends on the dimensions. That means how much current is steered by the each branch. So these two things are we need to combine. So for that one topology is required. That topology is called the Gilbert cell. So before going to Gilbert cell, we started the study from the variable voltage gain. Generally, variable voltage gain is one of the challenging tasks. So generally, whatever the amplifiers we have seen so far, they are fixed voltage gain amplifiers. Now we want variable voltage gain. Okay, so variable voltage means the gain should be varied. It's not a fixed one. Okay, generally with the VCRs are very having many applications in most of the communication circuits. Now this is the VCR circuit. It is looking like a differential pair, but what the difference is what? So in the M3, okay. So there in the differential pair, basic differential pair, what happened? The gate of the M3 is connected with the fixed bias to keep this transistor always in the saturation. But here is a V count. That based on the V count, the value of the amount of the voltage applied at the V count terminal. So what happened? The transistor operation changes. That means from one point to the another point. By that way, what happened? The current produced by the M3 also changes. Thereby, the current flowing in the branches also changes. So based on the changing of the current, definitely the gain will vary. Because the basic gain formula is GM into RB. GM into RB. Okay. So the GM is the transconductance, which is nothing but what? So how efficiently the transistor will convert the voltage into the current. That is the meaning of what? Yes. Clear? Yes. So this is the already we discussed about this one. Now variable gain. This is the two differential pairs. Generally, we want the gain in the earlier basis circuit. The gain variable gain you can get from the 0 to some value. Suppose if you want negative value to the positive value. So minus infinity to the infinity. For example, let us say you won't get from the infinity amount of the gain. But ideally, I can speak from minus infinity to plus infinity. So the range of the gain is more. How can you get that more range of gain, variable gain? So here is the basic under circuit. In this circuit, two differential pairs we can see. One is the right hand side, one more is left hand side. Okay. So and two tail currents each carries the what is the term? V control 1 and V control 2. So based on that, so if V control 1 is equal to V control 2, the currents are same, both will be cancel each other, then the gain is 0. Gain is 0. So if V count 1 is more than the count 2, then you may get the negative amount of the gain. Suppose V count 2 is more than the V count 1, you may get the positive value. If both are same, you will get the 0 gain. So like that, you are increasing the range of the gain, variation of the gain. So that is the two differential amplifiers, two differential pairs we have taken. But how can you match this? There are two that we see for V out 1 and V out 2. Two separate outputs are there. But we want only single output, from that we can collect this range of gain. So for that we need summing circuit. See, already I told you. So for one gain is for left hand side minus GMRD, for right hand side it's going to be a plus GMRD. This is circuit. This is one first amplifier, the second amplifier. Okay. So you need to connect these two inputs as well as outputs through a summing point. So then you can get directly the V out. Okay. So now your V out is from the circuit, your V out is varying from the minus GM into RD to plus GM into RD. This is the range. So yeah, after this, so everything we have discussed and we need to discuss it. So based on this, see, analogy, last analogy. So V out 1 plus V out is equal to RD into ID1 plus ID4 minus RD into ID2 minus ID3. So based on this analogy, the previous circuit, whatever the two separate differential pairs are there, we can combine into single. Okay, so first and fourth transistor should be connected to the one input, and second and third. No. Class 7 class 7. Hello. మన ప్రతి ఒక్క సంస్థ ఆ పంపిణీ నుంచి ప్రతి మనం అలా చేసి వర్తనం కదా దాని గురించి కొంచెం రైట్ హ్యాండ్ సైడ్ కనిపిస్తుంది ఓకే కొంచెం బాగా రైట్ రైట్ హ్యాండ్ సైడ్ ఓకే రైట్ కనిపిస్తుంది బోర్డు కూడా ఉంటుంది కొంచెం బ్యాక్ కనిపించాలి రెండు బ్యాక్ కూడా పడుతుంది అదే మనం దాని గురించి చెప్తుంది దాని గురించి హెచ్పిసిఎల్ క్వార్టర్స్ సో second transistor and third transistor, okay, first transistor, fourth transistor, because they both are doing the same thing, so that you can combine these two transistors. You can combine these two transistors. Combine means you can connect all the terminals. So in what way means, here is I am showing the picture. Yes, first and fourth are joined, second and third are joined, drains and sources are joined. Okay, gates are different, of course. This is the gate V in and V in is circuit. This is circuit. Okay, got my point? Now, see, this circuit is, if I1 is 0, I1 is 0, this current is 0. Okay, this current is 0, this path is not working. Only this is 3 and yes, 4 is working. So now 3 and 4 or 2, 3 and 2 is working. So that now your gain is plus GMRT. If I2 is 0, means this is 0, means E count is 0, then this current is 0. So now, so 1 and 4 will work, 1 and 4 will work. So thereby you will get the minus GMRT. So if both the currents are same, then equal gains you will get, both become 0. Yeah. So this is the circuit. Just the difference between this circuit and this circuit is very simple. Here just M1, M4, M2, M3. These are the two differential transistors. And apart from this, we need to add 2 more transistors. This is like this. Because the control, okay, we are giving a control current source. Okay, for that we control our voltage applied. So if not like that, as the basic VGA, what happened? So V control 1 is applied to the M5 and the transistor, and V control 2 is applied to the M6 transistor. So another current source is given there. Yes. So finally, this configuration I can bring to a very good looking. Okay, very simple looking to look very simple. So what to do here? See, I think M1 and M4 we can keep one side, and M2, M3 you can keep another side. So both the gates for this and for that, both the gates can be tiled and apply the same input. So that is by doing off like that. So you can get like this. Here see, so M1 and M3, sorry, M3, M4, M2. Okay, these are joined like this. M1 and M3, yes, M4. These are joined like this. So like this is, the rest of things are same. Okay, so this is. Now, yes, after Gilbert cell, so what is the main interest of Gilbert cell is simply what? To get the variable gain from a long range, more range, whose range of variable gain. With cascade structure, what is the meaning of cascade sitting of? One transistor on the head of the another. With the cascade structure, Gilbert cell consumes the higher voltage headroom than the simple differential. Of course, simple one and Gilbert cell, if you compare, so your Gilbert cell will consume because of having more number of cascades. See, here is in the previous picture. If you see, here is the this total is. So these are the what? Two differential pairs. Am I correct? Two different. They are stacked on the top of the this one. This is what? Control differential pair. This is what? Control. This is also differential pair, of course, but control differential pair. This is the what? So two differential pair circuits or amplifiers. So these four transistors or these two differential pairs are sitting over this control differential pair are stacked over the. So what is that one? This one. So that because two differential pairs M1, M2, and M3, M4 are stacked on the top of the control differential pair. I told you this is the control differential pair is nothing but M5 and M6. The bottom. Okay. So the bottom. And on the head of the this M5 and M6, there are four transistors. So they are stacked. Stacked means what? So connected. So connected. Stacking means arranging in the like this parts. Okay. So now suppose the differential input Vin, we are applying for the top two differential pairs. Vin is equal to, let us say, as our old assumption, Vin, suppose in the Vin place, if you apply the what? Common mode input voltage. Common mode input voltage. Okay. So then, suppose the differential input Vin is equal to VNCM, input common mode voltage. In the previous figure, what is the figure I shown? The Gilbert cell. Then what happened? VA is equal to VB is equal to voltage at node A, voltage at node B is equal to. So input common mode voltage minus VGS1. This is okay. So I want to show you here. See, this node is the VA node. This node is the VB node. This node voltage, whenever this is the VN is equal to, so VCM in. Okay. So what happened? This voltage is equal to this one. VA is equal to VB is equal to what? V control 1 minus what is that one? V input voltage V in CM minus VGS1. What is the VGS? Already you know this is the VGS1. This side is, this point is different than this one. So what is input here? V in CM. So V in CM, the gate potential V in CM minus this is what? VGS1. That is the VA. Similarly, if you want to VB, both are same, of course. So same voltage applied, so that V in CM. So minus this volt, this threshold voltage. Because M1, M2, M3, M4, all are the similar type of devices. So everybody is having the same threshold voltage. Okay, so VGS1. Okay, here is VGS3. VGS3. Okay. Okay. So next one is, so where M1, M4 are assumed identical. M1 to M4, both are identical. So for M5 and M6, that means control differential pair, bottom. So to operate in the saturation, the CM common mode level of V control, comma, so VMC control must be, this is the condition. So V in CM, I will convert as, myself is asking, questioning myself, like M5, M6 should be operated in the saturation. What should be the control voltage and what should be the voltage applied to the differential pairs? That is the VNCM. What is this voltage? I can compile it known as the amount of the control voltage and common voltage should be. So this is the condition. What is that one? The voltage of input CM control is less than or equal to, so V in CM minus VGS1 plus VTH of 5 and 6. So of course 5 and 6 both are same. Both are identical transistors. That's why VTH is same for both. How do you get this one? Okay, anyhow, first of all, I want to explain this one. So the controlled voltage should be less than the input common mode value. Why? Because means if control voltage is more, then it permanently goes to saturation. Okay, so that first make it lower, then apply the CM value, VLCM value, then increase this. So that initially what I'm saying is your control voltage, whatever control voltage you are applying to the M5 and M6 transistor should be less than or equal to the, so input voltage you are applying to the what? So both the differential phase, okay, minus VGS1, I told you, the gate to source of first transistor, or from third transistor, fourth transistor from this side. So plus VTH of bottom transistors. Clear? Here. So what is that one? The amount of the control voltage applied here is, okay, what is the one amount of the voltage? This should be, this voltage should be less than or equal to, first, this is what is the voltage, this one? V in CM value, V in CM value, minus, what is this voltage? VGS1, VGS1, minus, take the KVL like this. Then here is the VTH plus VTH of 5,6. That's it. Or you can take from this side also, no problem. So you cannot get any voltage drop across this current source. Yeah, since VGS1 minus VTH is roughly equal to the 1 overdrive voltage. Okay. Okay, and what is the conclusion of this one? Control voltage, which is applied to the M5 and M4 and M5 and M6, sorry. So must be lower than the input threshold voltage or input CM value. How much? By this value. At least by this value. Clear? Then only the circuit will be there, because you are applying the two input signals. Of course, include the VDD, you can have a 3 biasing circuits. One is the VDD, one more is the control voltage, and one more is the VCM. Which one should be more? Which one should be less? So otherwise, what happens if you are without any knowing, if you apply for VDD is more or VIN is more or what is the word? Control voltage is more, then you will not get the whatever the desired operation. So that we need to maintain. Suppose this is 5 volts, then what should be the control voltage? Suppose input CM value is 2 volts, then what should be the control voltage? It should be more or less. You need to choose. Okay. So further is saying what? Always your control voltage should be less than the common mode voltage. Okay. You should choose the voltages like that. Then you will get whatever the operation you want. That means what is the basic operation you want? You need the variable voltage gain. Okay. In Gilbert cell topology, to vary the gain of each differential pair to its center. Of course, in Gilbert cell topology, whatever the Gilbert cell we have, so to vary the gain of each differential pair. How many differential pairs are there? 2. To vary the gain of each differential pair. So through its tail current, definitely tail current will steer it. So thereby applying the control voltage to the bottom pair and input signal to the top pairs. Okay. So what happened? Interestingly, the order can interchange or can be exchanged while still applying the VGA. Okay. So in the figure, so I will show the figure. The idea is converted to the voltage. What M1 and M4? What will do? M5 and M6. First picture, actually Gilbert cell picture. No, nothing more. Whatever the Gilbert cell you have seen, that one. So it's what is the main intention? What is the main role is to convert the input voltage to the current by means of 5 and 6. What is the role of the 5 and 6? So whatever the input they are connected, it will be converted to the current. Okay, and whatever the current they produce 5 and 6, that can be routed to the M1 to M4 transistors. Upward, the current is going to the upward direction. Okay. So in the picture B, okay, B count is very positive, very positive. Okay, then what happened? Only M1, M3 are on, and your gain is equal to GM of 5 and 6 is multiplied with the V out is equal to RD into V. Similarly, if V count is negative, then M2 and M4 will be on, and your output is negative value of the same thing. So for the zero differential control, suppose there is no control input, then I think all outputs are zero. See, this is the Gilbert cell, you know, and here is the V in is positive. The V control is positive. This V control is positive. Understand? When this V control is positive, what happens? M1, M3 is on, and remaining two transistors are off. Because this is positive, these are negative. Okay, they want negative. So this is the circuit. Okay, this part is open. So I can show you by opening up these two transistors. Okay, then you will get the negative gain. Suppose this V count is negative, then these two transistors will be operate and these two will be off. So that this is looking like this. Yeah, this is the total three circuits. See, Gilbert cell sensing the input voltage by the bottom differential pair. Yeah, these two will take this input and convert into the current, and that current will be passing towards these transistors. Whatever the current is flowing here, that can be, yes, it's flowing like this. So this is flowing like this. That's it. Okay. So and second, this picture is signal part for very positive V count. If V count is positive, these two are open, remove, and this is the path of the what current. This is the path of the current value. For negative value, these two are on and these are, I think, open. So that this is the path. Yeah. So this is the picture B. V count is very positive. Only M1, M3 on, and V out is equal to GM of whose 5 and 6 into RD into V input voltage. Similarly, if V count is negative, then M2, M4 on, and M1, M3 will be off, and now the gain is equal to minus GM, same 5, 6 RD into V. That's it. Okay, for zero differential control voltage, V out is equal to 0. The input differential pair may incorporate degeneration to the provide linear to voltage, linear voltage to current conversion. Got my point? So this is the ending of this differential amplifiers. Any doubts? So here in this differential amplifier, what we studied, just I will go one by one. What is a differential amplifier? Okay. So what is a single-ended and differential operation? First, basic differential operation. This is what is the advantage of single-ended differential amplifiers? Single-ended operation, double-ended operation. Next, advantage of differential. So one is the voltage signal of single. Next, high immunity. Next, common mode rejection. And differential signaling is the increasing the maximum single. So these are the advantages. Next, basic differential. This is the basic differential circuit. So now this basic circuit, here is two grounds are there. You can join. Yes. Yeah, you will get like this. Join and one current source will be connected to this one. This is called the tail connector. So later, what is the qualitative analysis? How the voltage characteristics are varying. So this is the voltage characteristics of the each side, because there are two outputs are there. So this is one output, this is one more output. So this is one output, one more output. So they are varying from V in 1 to V in 2 minus difference. It may be negative value to positive value. This is the qualitative analysis. Same. Next, this is the final differential Okay. Next, quantitative analysis. In this large signal behavior, we studied it. This is the large signal behavior. Large signal behavior means what? Variation of the input voltage from 0 to VDD, VDD to 0. That is large signal variation. Next, half circuit method. So generally we have two methods to find the sequence input. We have superposition theorem and the half circuit method. This is the half circuit method. So the concept of the method is dividing like this. Okay. And one is varying like this, D into is varying like this. But finally, by using the Thevenin equivalence, so this circuit, your differential phase circuit, you can divide like this. Okay. So based on the half circuit, this you can convert like this, you can convert like this, and finally, so this whatever the gate potential supplied for M1 and M2 is V in 1 plus V in 2 by 2. Next differential pair, degenerated differential pair. It is nothing but CS amplifier with degenerated resistor load. So same thing. So here is a two resistors are added. Here two resistors are added for the basic differential pair circuit. Two resistors. Because of these two resistors, what happened? Gain little bit increases. Yeah, your gain little bit increases and you will get the linear gain. This is the what we are getting. In the earlier we got this one. Now we got this one. Thick line. Yeah, so because of that one, the differential pair circuit can be divided like this, can be converted like this. Next, common mode response. Apply the small change at this point. So the same change is applied to both the gates. So at X and Y, you will get the variation. Yeah, so based on that concept, you can join, because as I told you, so for any change at this point, corresponding and equal and opposite changes you will take here. You will get here X and Y nodes. So that parallel RD by 2 equals to. This is the two transistors. This is called the composite cell, composite transistor M1 plus M2, and this is the RSS. So another thing is, suppose this R earlier this is RD, this is RD. Now suppose if any resistor is changing, RD is changing by a small amount, then definitely what happens, that branch will be leads to more resistance. So that what things will happen. This is the things will happen. Next, differential pairs with mass loads. So earlier the loads are resistors. Now we need to convert them into with the mass devices, mass transistor. So this is the one type of arrangement. This is another type of arrangement. This arrangement is called the diode connected loads. This arrangement is called the what? Current source loads. So in the diode connected loads, this is the diode connected loads. In this, to increase the gain, to increase the voltage, what to do? So two current source, this side one current source, this side one current sources join. So with this, what happened? Whatever the currents of M1, M2, that is 100% of current, only 80% is flowing through this one, through M5 and M6, and rest of the 20% is flowing through the M3 and M4. So thereby, the load, the currents flowing in the M3 and M4 reduces. Thereby, the resistance of this M3 is say R3. So the drop is only just R3 into small current. So like that, you can increase the output voltage. Yeah. So now again the diode connected loads are the circuit is replaced with a RD. So thereby what happened? Then in the previous case, because there are two diode connected transistors are there. So there at any cost you will get the output less than the one threshold voltage of device. At any time, because the transistor, 2 diodes should be on, each diode should be on to on each diode. So VTH is minimum required. So that always the drop across diode connected load is VTH, minimum load, minimum voltage drop. So that is maintained. So I don't want to maintain like that. I want to reduce as possible as. For that, in place of diodes, I took the resistors RD and RD, because RD value is in your hand, so that you can control it. Yeah. So this is same thing. This circuit now, suppose RD values are infinite. RD values, because I want to flow very minimum current through these branches. Thereby I can reduce the drops. Okay. So if RD is infinite, I think infinite resistance can be shown by opening this two RDs. So then your circuit is looking like this is the second circuit of the beginning. Beginning means what? Differential loads. Okay, that is called what? Current source load differential. Yeah. Now cascading generally. So this you know about this one. This is the differential page, and this is one current source. This is one current source. This one, of course, all are connected in the cascading differential page. So 1, 2, 3, 4. These are the six transistors pairs. 3 pairs or 6 transistors are there. So they are used for the they are connected in the cascading manner to increase the gain. Short circuit of the cascade circuit is bisecting. We got this one. Now Gilbert cell. Today already once again I repeated about the Gilbert cell. So the Gilbert cell explanation starts with the VGA. So in VGA, what happened? The difference between the VGA and what is that one? Difference there is what? So whatever the empty transistor which carries the whose gate carries the V count value, then gate carries the or connected to a fixed voltage. Because there should be the transistor empty should be connected in the operated in the saturation. And these are the two things. I think two different ways. Okay. So this will give the output of V out 1. This will give the V out 2. Okay. So, but I want to merge these two circuits to be a single circuit. Thereby, I can get directly the V out. So, for that, some tips we used. So, this is one of the basic methodology. So, concept explained. So, then finally, we got like this. And now the circuit this is the summation in the current domain. So now this I1 and I2 are replaced with this current source are replaced with the mass constant once again. So that is the M5 and M6. So that is like this. Okay. So now what happens? So after rearranging the devices, then you get this structure. This is called the Gilbert topology. So in the Gilbert topology, this is the control differential pair. These are the differential pairs, two differential pairs actually. So and one more thing is what is the minimum? Suppose if input voltage is equal to input voltage applied to the differential pairs is equal to what is that V in Cm. Okay, then what should be the control voltage? So for that, this is the condition. Next, I think the three circuits here, this is the Gilbert cell. In this, M5 and M6 will take the input voltage and convert into current, and the current is routed to the RD like this through these branches. Okay, now suppose this V count value is positive, then these two are on, these two are off. So that this is the equal circuit. Suppose this V count is negative, these two will be off and those two will be on. So this is the way I think the operation is going on. Yes. Now you can tell me any doubts?
Sir, వీటి రికార్డింగ్స్ కావాలి.
ఎవరు?
వీటి రికార్డింగ్స్
ఇస్తామండి. ఇస్తాం. కొంచెం బిజీగా ఉన్నాము.
ఓకే.
చెప్పండి. సౌండ్ వస్తుంది బాగా.
విజయశ్రీ మేడం ఏదో అడుగుతున్నారు.
నేనేం అడగట్లేదు మేడం. పిలుస్తున్నారని అన్మ్యూట్ చేశాను.
అదా ఏంటో బుస్ బుస్ అని ఎవరో
నేను ఇప్పుడే అన్మ్యూట్ చేశాను.
అదంతా రామకృష్ణ గారి ఉంటుంది. చెప్తారు మీరు మ్యూట్ చేయండి. చూసారా అయిపోయింది. ఓకే ఓకే
సిపియు రన్ అవుతుంది సార్, అదే సౌండ్ కావచ్చు.
ఓకే ఓకే సార్ ఇంకా ఎందుకు రాను సిపియూ ఉన్నాయండి. ఫస్ట్ జనరేషన్ సిపియూ అంటే
రీసెంట్ గా మార్చేసారు సిస్టమ్, అది ఫుల్ సౌండ్ వస్తుంది.
ఓకే ఓకే దెన్